Okay, so let's talk about if statements in Java. So fortunately, we have some slides directly related to that, and I'll go open them up. So we have these slides here, which again I'll make sure are shared with you on the Google Drive site. So let's talk about if statements. So if statements in Java come in two basic varieties. They can come in a way that checks a condition, performs an action if that condition is true specifically, or a variety where you can say, if this condition, then do this, else do this other thing. However, there's a special version of this one where it sounds like it's very similar to what you're needing, okay? So it'll be something like this. Let's go insert something here. So suppose we were to say when someone comes in here, if time equals 0.0, then trace ln, I'm the first person infected. Something like that, right? This would be the first type of, or this is the first person infected, okay? This is the first type of if statement. Now, you could say else, trace ln, this is a contrived example, trace ln, this was infected after the initial time, okay? But I think what you're asking is, could you have multiple cases here, right? So could you say, for example, okay, time 0, time less than 50, time greater than 50. So then you can do else if, time, you would never do it this way. You'd declare a variable, current time equal time, just to remember the name of that, give it a nice name of that variable, that value that was returned by time. We'll give it a nice name called current time, and then we'll say if current time equals 0, do this. If else if current time is less than 50, then was infected, early in the simulation. And then we could have, else if they're infected before 75, was infected in the middle of the simulation, and then we could have a final, else was infected at the end of the simulation, or something like that. So here we have multiple cases captured, and we do it by weaving together this if together with this. Conceptually, what's going on is you have something like this. These are sort of nested inside. This is at a conceptual level what's going on. And in fact, the Java so-called compiler, the thing that actually processes it, will sort of interpret it like this. But the nice way to write it, you can write it like this. So this is one way to handle it, okay? One way to handle these kind of multi-way, multi-case situations. That's one way. Was that helpful for your question? And I'll show you another way.
I guess you can always put directly Java code in there.
In where? In this thing? And the action, this is Java code.
Yes, but before you were using this, a question mark.
Oh, okay. There's a big difference, and thank you for raising this question because it's germane to this group. There's a big difference between an if statement and an if and a conditional expression. It kind of works like an if. An if statement is something that does different things depending on the condition is true or not. So here we are doing something. So if it's equal to 0, we do this, we print out something here. if it's not true, we do this. We're printing out something there. That's a different thing than a conditional expression. Okay, let's take the conditional expression. Let's go do that. So let's go take a look at a conditional expression. That's, for example, this thing here. Let's do it. Let's do it this. No, we did it with color here. Gender, ethnicity, sure, and this guy here. Yeah, good. Sorry. Let's go to the population here. So here, example, right? This is an if expression. What this means is it's a formula. It's determining a value. That other case we just looked at, it was going to do something. It was going to tell it, like, do this or do this, depending on how it turns out. Here, the purpose is different. We're not telling it to do it. We're trying to determine a value that results from this. So either it's value sex.female or sex.male. In both cases, it's saying, is this thing true? If so, the consequences are different. But here, it's saying if this is true, then the value is sex.female. Otherwise, the value is sex.male. In the other cases, it was saying if this thing is true, print this out. Otherwise, print that out. No value is being calculated there. So this is used to determine a value that's set for their sex. The other thing was just taking an action. It's undertaking an action. If this thing is true, it does one action. Otherwise, it does this other action. So here we can't use an if. An if is a statement. It actually does something. Instead, we use this so-called ternary operator. Now, if you're asking, how can we do more than two cases? Okay. Well, the cheating way is to do it with this. But random from ethnicities.value. Well, it's not cheating. I mean, it's an easy way to do it. That's one way if you have a bunch of values. Another way, if we wanted to do it manually, we could do that. It wouldn't be particularly beautiful, but I will show it to you. Okay? Do you want me to show it to you? Okay, you promise you won't sue me or something, right? Okay, so let's comment that out. So ethnicity, okay. Suppose I wanted each of the three values of ethnicity to be to have a 33% chance of being invoked. Okay, so random true this. Then we'll take ethnicity dot African American. Otherwise, and this is where the recursion begins. Otherwise, if it's not the case, then if random true actually in this case it's 0.5, right? Because we only have two choices. Ethnicity dot Caucasian. Otherwise, ethnicity dot Hispanic. Okay, so let's learn to read this. Okay, if this is true, if we roll the dice, a three-sided dice, so to speak, and if that comes up true, then we're African American. Otherwise, it's one of these two values. So with 50% probability, it'll be this. 50% probability, it will be that. Does that make sense? You can, and this is just the ugly way of doing it with that. Another way that would be considerably more beautiful would be you could actually do this. You could say ethnicity dot. So this isn't beautiful, but it's less ugly in my eyes. You can say dot length. Uniform discrete between 0 and this one minus 1. That ain't too beautiful. So here we draw a value that's between 0 and, in this case, it's 2. So 3 minus 1 is 2. And then we look up that particular ethnicity value. Okay? So we draw it with uniform likelihood from any of these values. Okay? So that's a way to do it. You could also define a custom distribution. If you want to impose a custom distribution, instead of calling random uniform, I could have custom distribution in here that I invoke, but I would have to make it'd have to treat as an int, and so you could do that. If you wanted a custom distribution here, what model am I in anyway? I'm in this one. Okay, fine. So if I wanted to introduce a custom distribution, I could do so here, and I could implement that here, and I say this is custom distribution for ethnicity, and I want it to be discrete, and I want it to be from 0 to 1, it has 10, and 1 to 2. Okay. Excuse me. Actually, I see. You can specify using either ranges or this. Yeah. So 0, 1 is 10. 1 to 2. Actually, maybe I'll just for discrete distribution, I'll just make it. It looks like you can actually specify for options, and you can specify an options list. Sweet. Sweet. Okay. Number of observations: 10, 30, and 20, or something like that. There's my custom distribution, and this will actually return. This will return one of those options, and with that frequency, and we can go back to the population, and we can say, I think then we could just do custom distribution here, and just draw from it. Is that sweet or what? That's pretty good. Okay. So here we can specify an empirical distribution with a certain relative frequency, and or we could do it with certain values that are discrete in character, or we could do it continuous in continuous space. So here I think they're integers, integer values, but this is often what you'd need. Okay. So there you don't have to impose a uniform assumption. You can just draw it from here. Okay? Okay. Yes. Yeah, indeed. Okay. So thank you very much. Let's wrap that up. I welcome those questions. Bring them early, bring them often tomorrow. Okay?